Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Joe Jacobs.
And I'm Kate Jackson.
And we are your hosts for episode 1 called The Chemistry of Beignets. Today we will be discussing the process of making beignets and the science behind it.
So, to start off, beignets, if you didn't know, are a kind of donut, and they're often covered in powdered sugar. And these beignets were brought by French settlers to Canada. And when the French were forced out of Canada by the British, the settlers moved then south into North America, bringing their cuisine and culture with them. Today, beignets are largely associated with the French Quarter in New Orleans.
So when we're making the dough, yeast and leavening agents are the foundation of the process. Without these types of ingredients, you wouldn't be able to have bread or beignets or really anything, and you would sort of just get little bricks of flour. Leavening agents or ingredients that make the beignets or whatever you're making rise participate in chemical reactions during various steps of the process. For example, yeast transforms any sugars in the dough into carbon dioxide gas and ethanol, which is a type of alcohol. The carbon dioxide that is trapped in the dough expands during the rising and resting process, which basically makes the dough increase in volume, and the alcohol produced by this fermentation reaction evaporates during the frying process. I wanted to point out that yeast is a living organism. You have to activate the yeast when you're making beignets or bread or really anything with yeast in it. And you have to make sure you keep the dough at a warm room temperature in order to make the yeast work quickly, but not too hot so that the yeast doesn't work at all, and not too cold so that the yeast is working really slowly. Essentially, fermentation is primarily responsible for the holes and just basically the rise and the flavor of the bread. The flavor inside the bread or beignets comes from the alcohol and other compounds produced through fermentation. And another notable reaction that occurs in the dough is aerobic respiration, and this occurs in the mitochondria of the yeast cells and performs until the limiting reagent, which in this case is diatomic oxygen, is used up. Then fermentation occurs second, and it's also known as anaerobic respiration because it happens without oxygen. And both reactions produce carbon dioxide, so they both contribute at least a little bit to the rise of the beignets. And the equation for fermentation is glucose turns into 2 molecules of ethanol and 2 molecules of carbon dioxide. And the equation for respiration is glucose plus 6 molecules of oxygen turns into 6 molecules of carbon dioxide and 6 molecules of water. In addition to these important chemical processes, one thing I found is that kneading the beignet dough adds air into the dough and speeds up the respiration process. This leads to a faster rise but less flavor because ethanol is responsible for flavor, and increasing O2 in the dough only speeds up the respiration reaction and not the fermentation reaction where ethanol is produced. So for our beignets that we're going to make this weekend, we're going to do sort of a slow rise and a slow rest and no kneading. And this is just basically so we can get the most flavor out of the dough, and also kneading is kind of annoying. And we're just following a recipe, and that's what it said to do. Kneading also develops gluten strands in the dough, which can make the beignets kind of tough, which is just the total opposite of what we want. And just for a little more chemistry, if we were to knead the dough, O2 would be added into the dough because air has O2 in it. And this would increase the rate of the respiration reaction because there are more molecules of O2 that are colliding with glucose in the dough, and more collisions leads to a higher rate of product formation because of a higher chance of the molecules colliding with sufficient energy and sufficient or required positioning. So that's just some of the stuff that happens behind the scenes when you make beignets. And Kate's going to talk a little bit about what happens when you actually fry the dough.
So, like Joe just mentioned, after we make the dough, we're going to need to cook them, obviously. Don't want to eat raw beignets. That would be not good. So the recipe says to fry the beignets in oil until they're golden brown and puffed up. The golden brown aspect of the beignets will be achieved through a process called caramelization, as well as the Maillard reaction. I'm going to focus on caramelization because it's a really complex process. So caramelization is when the maltose carbohydrate molecules, which is basically just 2 glucose molecules in the dough, are going to start to break down and rearrange themselves under heat. The process, like I said, is a lot more complicated than it might seem, and scientists are still trying to fully understand it and define it. As sugar appears to merely melt, it is actually undergoing several intricate chemical reactions. And the first one here is sucrose inversion, and that is when sucrose will break down into glucose and fructose. To give you a little bit of chemistry behind this, the sucrose will collide with water molecules and a hydrolysis reaction will occur. And that means that the water is used to break chemical bonds. In this case, the intramolecular bond between glucose and fructose, specifically a covalent bond called the glycidic linkage, which holds the 2 molecules together, will be broken. So the reaction here, like I mentioned, is pretty simple. What's really happening is the sucrose molecule, which is C12H22O11, is breaking in half, essentially, into 2 molecules, fructose and glucose, which are both C6H12O6. So 2 of those with the help of water. After this, condensation occurs. During the condensation, the sugars will lose water and react with each other. Then further dehydration will happen, just making sure all of the water has been lost. And the molecules will then fragment and polymerize. It is in these steps that characteristic caramel color and brown sugar flavor is happening. So the 3 main products from sucrose caramelization are the dehydration product, carmelon, and then 2 polymers, caramelene and caramelin. So caramelization is a separate process from the Maillard reaction. The Maillard reaction is a browning process, and caramelization will take place after the Maillard reaction and at a higher temperature. So the Maillard reaction is a chemical reaction between amino acids and reducing sugar that gives food its distinctive flavor, brown food that is, and foods that contain both carbohydrates and proteins, like beignets, brown from a combination of caramelization and the Maillard reaction. And then just to get into the personal connection and why Joe and I wanted to look into the chemistry of beignets. We both, first of all, just enjoy baking. Joe, I think a couple months ago, just dropped off some sourdough bread to my house.
I did.
And we just like to kind of exchange recipes and work together to find fun ones to make. So this seemed like a perfect opportunity to kind of explore a little bit. And then also, I don't know if you guys have ever watched like The Princess and the Frog, but
I just rewatched that movie. It's so good.
That movie, in that movie, Tiana makes what are probably like maybe the most amazing looking beignets ever. So we kind of wanted to test that out for ourselves. Mm-hmm. And then Joe's also going to Tulane next year, which is in New Orleans, and it's super close to the French Quarter. So he's had beignets a few times before, and we also just needed to really make sure he got into the culture before he went.
Yeah, I'm super excited to go to New Orleans this fall. I feel like beignets are just such a signature part of, visiting, being there, and they represent sort of a mixing of culture that really makes New Orleans so unique. And I actually visited in February this year, like you said, and the beignets I had at Café du Monde were just incredible. I ate them in the park, Jackson Square, right next to the cafe, and I got powdered sugar everywhere.
Yeah, that's like the place to get them.
Yeah.
You're gonna have beignets.
I know. It was such a good experience. I loved it. So yeah, we just wanted to kind of study them a little bit more. And I just hope when we make some this weekend, they turn out just as well.
I mean, I think they're definitely gonna be Café du Monde level.
Oh yeah, for sure. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit hvspn.com.
Thanks, guys.